Hey Angular folks, it's Brian. After many years of building with Angular, I'm here to help you level up your skills and build better apps. Ever wonder if there's a way to get all the power of reactivity in Angular without chaining together a dozen RxJS operators just to keep your UI in sync? Well, there's a better way using signals. Today, I'll show you how to move beyond observables and reveal the secret power of linkedSignal, combining multiple signals for truly modern, reactive Angular code. Ready to upgrade your components for the future? Let's dive in. Let's start by looking at what we're working with. For this tutorial, we have a basic product search. It has a product filter search box, category dropdown, and a big list of Angular-themed merch. When we type in the form, the list gets filtered down. Then we can choose a category to further filter it all down. Then we have this reset button. When we click it, the controls and the list reset back to their original state. This works fine, but let's look at how it's wired up under the hood. First up, let's check out the template for this component. For this example, we're not using Angular forms, just standard HTML form controls with values and events to update state and filter results. Here's our search field. For the value, we're using a search observable with the async pipe. Then when the input event fires, so when we type in the field, we call an update search method and pass it the value from our field. Then we have the category select with the same. A category observable for the value with the async pipe. And then when the category is changed, we call an update category method. Then here we have the reset button that calls a reset method when clicked. And then for the product list, we have a for loop using a filtered products observable with the async pipe as well. So that's the HTML, but on the TypeScript side, things are looking pretty RxJS-y. Here, we've got search and category as behavior subjects. Think of these as observable boxes that hold our latest search and category values. Then, down here, we have the update search and update category methods that are used to set the new values into those subjects whenever the user types or selects something. And below these, we have the reset method that resets the search and category observables to empty strings. And then we have the filtered products, which is a combo observable created with combine latest. This listens for both the search and category changes, pipes them through a debounce time, so we don't filter on every keystroke, then runs the filter logic. Everything is glued together with the async pipe in the template. This works, and honestly, it's not a bad pattern if you're living in RxJS land. But Angular has moved on, and so can we. Let's upgrade this to the new Signals API. If you're new to Signals, I'll try to explain things as I go, so don't worry, I've got your back. First, let's swap out the search and category behavior subjects for signals. To do this, we just need to use the signal function from Angular core. That's it. Now, search and category are signals. Now, since we're using signals for these, our update search and update category methods can go. Let's clean those out. Now, let's switch over to the template. Here, instead of using the async pipe and passing the value to an update function, we can bind the value to the new search signal and then update it directly with the set function. Same deal for the category. Signals are functions, so we call them with parentheses to read the value, and use the set method to update their values. Okay, that's all we need to do here, but now we need to update our filtering logic. Let's switch back over to the TypeScript. Instead of an RxJS pipeline, we're going to use Angular's new linkedSignal. This lets us create a writable signal that also updates based on another signal. So if you've ever seen or used linkedSignal before, you're probably familiar with the fact that you have a source signal and then a computation that will run when this source signal changes. It's pretty cool, right? But in this case, we have a problem. We are relying on more than one source signal, right? We have the search value, but then also the category. And when either of these change, we need to update the filtered products. Here's where it gets really cool. We can actually add multiple source signals. Instead of passing a single signal to the source, we pass a function that returns an object with both signal values. And then our computation receives both search and category, so we can use those to properly filter the products. To keep things tidy, let's create a helper method for our filter logic. Let's call it update filtered products and add parameters for the search term and the category. Then we can move our filtering logic into this method and remove the old setup for this. Okay, then we'll use this in our linkedSignal computation. So now we will properly filter our results, all signals based. When either of these signals change, we will update the filtered products signal based on the values of both signals. But here's a question. How do we debounce signal updates so we don't filter on every keystroke? Well, as far as I know, Angular's signals don't have built-in debounce yet. But the quickest way to do this is with the new signal observable interop. To do this, we'll create a new signal. Let's call it Debounce Search. What we're going to do is create an observable so that we can use the debounce time operator. Then we'll convert this observable back to a signal. So we'll use the toSignal function. This converts an observable to a signal. Then we'll use the toObservable function, which does the opposite. It converts a signal to an observable. Okay, now that it's an observable, we can add pipe and then use the debounce time operator to debounce this with a 300 millisecond timer. This is pretty funny, right? But it works pretty well. Now, there may totally be a better way to do this, and if there is, please let me know in the comments. Okay, now, in our linked signal, instead of using the raw search, we'll use debounce search in the source. And then, now that all of these are signals, we can update the reset function to reset all of these signals. This could probably be done more elegantly, but this will work for this example. The key here is that linked signal can also be written to. It's like a mix of a computed signal that updates when other signals are updated and a normal writable signal whose value can be set directly like we're doing here. Now that we're using signals instead of observables and async pipes, let's remove the async pipe and any other unused imports from the component too. Okay, now we just need to switch over to the template and update our filtered products to the signal. No more async pipe. Okay, hopefully that's everything we need. Let's save and check it out. Nice. Looks like it all works just like it did before with observables. But now it's done in a more modern reactive way with signals. So now our code is simpler and easier to reason about. We went from manual RxJS pipelines to a fully reactive, declarative approach using signals and linked signal. The old RxJS way works, but Angular's new signal-based reactivity is just cleaner. You can use this pattern anywhere you need to react to multiple sources. Filters, forms, dashboards, you name it. If you found this helpful, please like, subscribe, and share it with your favorite Angular friends. Until next time, thanks for watching.